Hey everyone, it's Justin again. At the end of the last video, you found out that you've been looking at the next quadratic form, Vertex Form, for several lessons now. In this video, we will officially introduce Vertex Form and why it's called that. By the end of this lesson, you will be able to graph quadratic functions written in Vertex Form. First, we'll quickly review Vertex Form and why it's called that, then practice finding vertices. You'll then be ready to learn how to graph parabolas from Vertex Form and get a chance to try it out with a few examples. This is Vertex Form. It's one of several forms you might see quadratic functions in. It's called Vertex Form because this form makes the vertex easy to identify. Remember those values that told us the translations, h and k? Well, those same values also tell us where the vertex is. The reason for that is pretty straightforward. If we take the parent parabola and translate it some distance, the whole graph, including the vertex, moves that far. At that point, the vertex won't be moved by any other transformation. We can stretch it, or compress it, or reflect it, but the vertex stays exactly where it translated to. The vertex is completely based on h and k. So let's do a few rapid-fire practice examples. What's the vertex of this parabola? The vertex is at 2, 3 to match the values of h and k. What's the vertex of this parabola? The vertex of this parabola would be at 5, -2. Did the negative k value fool you? Remember, h is subtracted and k is added, so rewrite the expression if necessary. Last one. What's the vertex of this parabola? The vertex is at -3, -1. This time we had to rewrite the inside as minus a negative to make up for the plus that we saw originally. Cool, so we can find the vertex now. This parabola's vertex is right here. But where's the rest of the graph? To graph the rest of the parabola, we need a bunch more points. The easiest way to get those is to just input a few values. Here's the trick though. Since parabolas are always symmetrical, we only need points on one side of the vertex because they'll just get mirrored on the other side. So let's try a couple inputs. If we input -2, then -2 plus 3 is 1, and then 1 squared is 1. 2 times 1 is 2, minus 1 leaves us with 1. So when we input -2, the output is 1. Next, we'll go another unit to the right and input -1. -1 plus 3 is 2, and 2 squared is 4. 2 times 4 gives us 8, and 8 minus 1 is 7. So when we input -2, the output is 7. So now we've got the vertex and 2 more points, or rather 4 more points, since the other side of the parabola is a mirror image of what we've already graphed. And since we've got so many points to guide us, it's a simple matter to draw the curve passing through them. Let's try a couple examples. How would we graph this function? First, pull out the vertex coordinates, 2, 1, which puts the vertex right here. Now we need to find a couple more points, which will be mirrored to total 4 points plus the vertex, which we can use to draw the graph. Let's use the inputs of 0 and 1 to start. When we input 1, 1 minus 2 is -1, -1 squared is 1, and -1/4 times 1 leaves the -1/4 the same. And when we add 1 to it, we get +3/4. So an input of 1 gives an output of 3/4. Now we can do the same thing with an input of 0. 0 minus 2 is -2. -2 squared is 4. -1/4 times 4 is -1. And -1 plus 1 is 0. So an input of 0 gives an output of 0. We could find more points, but this is a very good start. And luckily for us, those points mirror to the other side. What makes the inputs 0 and 4 special? Since they both have outputs of 0, we inadvertently found the roots of this function. And now that we've got a decent amount of points, we can draw the graph passing through them. Do you think you could do it on your own? Pause the video now and try to graph this function. Let's see how you did. The vertex is at -3, -1. Let's do a couple points to the left at -4 and -5. When we input -4, we get -2. For -5, it comes out to -5. We can mirror those values to the other side of the vertex and then graph the curve through all of these points. Graphing quadratic functions in vertex form really only takes 2 steps. Graph the vertex, then input 2 more values on either side of the vertex, which can be mirrored. In the next lesson, you'll learn how to use vertex form to answer questions about real-world scenarios. See you then!